So I made an equation 20 times 0.5 plus 1 half 20 times 1.5 plus 20 times 2 plus 1 half 10 times 2. Now, in this equation is 20 times 0.5. This represents the x, and the other side right here is 1 half times 20, 1.5. That will represent the y axle. So in the end, I will get 75 meters as my displacement for x particles. Let's move on to the next one. So C, what is the average acceleration of particles over the first 20 seconds? So in here, they're asking for from 20 seconds to acceleration. We already know that a second the acceleration is constant. So having the acceleration, the slope of the line. So let's see here. We already know that there's at the end is 2, and then 0.5 is x. So we need to find where it intersect, and it intersect to 20. Okay. So we already know that the total will be asking for 20. But also the fact is we've already found x and y. So let's go to draw it out for a second. So let me do this here. Just do it here. Cut out and then switch. Alright, so 2 is right here. So that's for y. This is for y. This is for y. Minus 0.5. This is for x. I believe, yep. It's x and it's y, but you know, velocity and time, but I'm going to use that. And then divide by 20, since in total is be 20. So equal that. So 2 minus 0.5 divided by 20. We get a fraction, and then we put that into a decimal, and that will be 0.075 meter second square. Okay. Let me switch here. So D is asked for what is the intensify acceleration A of the particles at time and 45.0 seconds. So let's see here. 1 meter second square, 0.20 meters second square, minus negative 20 meter second square, 0.222 second square. What you need to do in this situation is what you need to do is that you need to divide. So think of this as for this to find acceleration. So you get A equals y divided by time, t. Okay, so let's find the time and let's find the y. So 45 seconds. Okay, so we already know that it's at 10. 10 is where it's at. But also also it's minus 2, so don't forget about that, because it's going down the acceleration. So let's see here. So 2. So negative 2 over 10. Negative 2 over 10 will equal negative 0.20 meter over second square. So that's how you get that. Because you divide y. Well, actually no. Let me put this in the correct term. You divide the velocity a meter in seconds has to represent y, and you divide by time, which is x seconds, and that's how you get meter second square. Because I divide, divide 2 over 10. E. Which part of the graph showing correct acceleration versus time plot for the motion described in the previous part? So you got 4 graphs, and you're looking for to find the correct acceleration versus time from the previous part, which is important. So the previous part is asking right here. We already found the acceleration is negative 20 meter second square. So we already know that's going down. So time is constant while acceleration is decreasing. So it's not C, obviously, because when acceleration drops immediately, and this represent it's not represent time, it's not represent acceleration, but also represent time. So this C is not right. Time is constant, but acceleration is going up. So D is not right. So we leave A and B. Okay, so we are looking at the graph. We just need to find which one that represent it, and knowing that 20 and 30, 20 and 40, it stop. Well, how to say this? It stop and it's constant. It just keep going straight to 20 and 40, and this is exactly the same thing, 20 to 40, and then drop down the acceleration. So the correct graph for acceleration versus time is B, and that's how you do velocity versus time graph. Can tell you.